Guys, in this content, we are going to define some terms of mathematics in the modern world. So, let's have no further ado. Let's get to it. So, mathematics in the modern world. We have here symmetry. It refers to the condition of an object that is invariant under some transformations, including translations, reflections, rotation, or scaling. So, when you say invariant, guys, it is when you say invariant, it is specifically unchanged by specified mathematical or physical operations or transformations. So, natay examples diri. Example of symmetry, bilateral symmetry, which mostly on butterfly. Butterfly siya, guys. Radial symmetry, which sa either starships, starships, and sixfold symmetry, spherical symmetry. So, rotational symmetry. Ang kaning rotational symmetry, guys, wala siya karang matawag po siya og karang, for example, starships. Starships. So, when you turn imo siyang tuyokon bitaw. So, the same lang gihapon siya porma bisag unsaon nimo siya og tuyok, and that is symmetry. So, we have fractals. So, fractals are any of various extremely irregular curves or shapes for which any suitable chosen part, similar in shape to a given larger or smaller part when magnified or reduced to the same size. So, example of fractals, guys, Koch snowflakes and Mandelbrot set. So, a fractal is a never-ending pattern that repeats itself at different scales. This property is called self-similarity. So, guys, although fractals are very complex, they are made by repeating a simple process. So, bisag unsaon nimo siya kuan, mao lang gapon iyahang porma. Same siya sa symmetry. So, where do we find fractals, guys? Makapangita taning fractals in nature or in math. So, in natural fractals, guys, include branching patterns like trees, river networks, lightning bolts, blood vessels, or etc. That spiral patterns like seashells, hurricanes, and galaxies. So, when we find fractals in math, guys, because mathematical fractals like this Mandelbrot set are formed by calculating a sample equations thousands of times, feeding the answer back into the start. These fractals are infinitely complex, meaning we can zoom in or in forever. So, naputay a fractal triangle, guys. A fractal triangle is formed by a simple repetition. The infinite Mandelbrot set is formed by repeating a tremendously simple calculation. Simplicity leads to complexity. A fractal tells a story of the process that created it. So, next, tessellation. So, tessellation is to tessellate a shape. It must be able to exactly surround a point or the sum of the angles around each point in a tessellation must be 360 degree. The only regular polygons with this feature are triangles, squares, and regular hexagons. Just like here in the example, guys. So we have different shapes na atong nakita. So that is tessellation. So tessellation is the property of or fact of tessellating. So when you say tessellating kasi, guys, tessellating means to form into or adorn with mosaic. So that is tessellation. That is tessellating. a covering of an infinite geometric plane without gaps or overlaps by congruent plane figures of one type or a few types. So, muna siya guys, when you see these examples, nadyan siya na formang laing-lain nga anong shapes. That's what we call as tessellation. So, tessellation is a tiling pattern with no gaps, the result of tessellating an area or plane. A less common name or polygon for polygon tessellation. So, tessellation of a flat surface is the covering of a plane using one or more geometric shapes called tiles with no overlaps or no gaps. So, in mathematics, tessellation can be generalized to higher dimensions and a variety of geometries. So, spiral. Spiral is a curve which emanates from a point, moving farther away as it revolves around the point. So, examples of spirals, guys. Nautilus shell depicting logarithmic growth. So, spiral. So, naa siya spiral. So, ano ni siya ang spiral, guys? Kani? Ano siya? Wala siya gana ba? Mag-ana na siya. So, another example is Fermat spiral, presents in the seed head of sunflower. So, spiral or a plane curve that in general winds around a point while moving ever farther. So, parehas anis akong gibuhat kani siya guys. From a point moving ever farther from the point. Many kinds of spiral are known, the first dating from the days of ancient Greece. The curves are observed in nature, and human beings have used them in machines and in ornament, notably architectural. For example, the whorl in Ionic capital, and the most famous spirals are described below. Or kani siya guys, kani siya akong gihimo. Kani siya kana. Kay mo spiral of Archimedes na siya. Only use geometry to study the curve that bears his name. In modern notation, it is given by the equation r is equals to a theta, in which a is a constant, r is the length of the radius from the center or beginning of the spiral, and theta is the angular position, amount of rotation of the radius. So we have here probability. It's the branch of mathematics concerning numerical descriptions of how likely an event is to occur, or how likely it is that a proposition is true. So the probability of an event is a number between 0 and 1, where roughly speaking, 0 indicates impossibility of the event and 1 indicates certainty. So in math, guys, probability is the number of ways of achieving success, the total number of possible outcomes. For example, flipping a coin or tossing a coin. So the probability of flipping a coin at being heads is 1/2 siya, guys, because there is a one way of getting ahead and total number of possible outcomes is 2, a head or tail. So so here in our examples, here sa atong example, guys, sa atong image, so nadyan siya kanang kuan na siya 1/2 certain nga ma-head jud siya and 1/2 certain or unlikely nga di jud siya ma-head. So mao siya ang probability. So there are percents there are what we call is possible outcomes that makuha sa nimo in a certain kung unsa jud imong ganahan nga kuan. So naatay 1 chance sa dice and 4 in 5 chance sa bola. So mao na siya, guys. ang probability. We have here geometric design. So geometric design, guys, is a branch of competition. Geometry. It deals with the construction and representation of freeform curves, surfaces, volumes, and is closely related to geometric modeling. So, such as this image, guys. So, nag-represent just karang curves, surfaces, and volumes nga related just geometric modeling. So, geometric design is a fun trend that focuses on the simplistic beauty of mixing certain shapes, lines, and curves together for creative results. You may have seen it incorporated into fresh tattoo designs, abstract backgrounds, and even in jewelry design. And you can mix these modern elements into your work by creating some shapes that it could results to geometric design. So correlation. The word correlation is made of co means together and relation. It refers also to the degree of correspondence or relationship between two variables. So when two sets of data are strongly linked together, we say they have a high correlation, guys. So when correlation is positive when the values increases together, and correlation is negative when one value decreases as the other increases. So correlation can have a value. 1 is a perfect positive correlation. 0 is no correlation. The values doesn't seem linked at all. And negative 1 is a perfect negative correlation. So example, guys, ice cream. So the local ice cream shops keep track of how much ice cream they sell versus in the temperature on that day. Here are their figures for the last 12 days. So we have temperature 4.2 degrees, 16.4, 11.9, 15.2, 18.5, 22.1, 19.4, 25.1, 23.4, 18.1, 22.6, 72.2 degree. So ice cream sales, we have $215, $325, $185, $332, $406, $522, $412, $614, $544, $421, $445, and $408. So to know that they can track of how much ice cream they sell versus the temperature in that day. So we have here a scatter plot. And so as you can see, guys, nagkataas ilang sale sa temperature. Nagkataas po ilang sale o nagkakuan po sa temperature. Nagbase sila sa temperature niya, nagkataas ilahang sale. That we can easily see that the warmer weather and higher sales go together. The relationship is good but not perfect. Yun siya kay naman siya mutaas siya, muubos, mutaas na pod, muubos. So in fact, the correlation is something like it's not perfect but it's good. So rhombus versus square. A square is a four-sided polygon. A square is a four-sided polygon which has all its sides equal in length and all the angles are equal to 90 degrees. The length of the diagonals is also equal. So while the rhombus is also a four-sided polygon and all the sides are equal in length, but the opposite angles of a rhombus are equal and the diagonal bisect at each other at 90 degrees. So the diagonal length of a square area of the same measure, and the diagonal of the length of a rhombus are of different measures. So the square is all the interior angles of squares measures 90 degrees. So that is a right angle. In a rhombus, the opposite angles area of the same measure. So the key difference between square and rhombus is square has all its angle equal to 90 degrees, but rhombus does not have. But both the shapes have all their sides as equal. The below figure to know the difference. So we have here square and rhombus shapes. So we have here a parallelogram versus quadrilateral. A parallelogram is a two-dimensional structure that has four sides, of which the sides that are opposite are also parallel and of the same length. So while a quadrilateral is a two-dimensional structure that always has four sides and four corners. So a parallelogram is a geometric two-dimensional shape which is named for the fact that it has opposite parallel sides. So a parallelogram can be divided into two triangles that are congruent, and the alternating interior angles formed by the line dividing the object into triangles are equals. So the sides that are corresponding of two separate triangles will also be of equal length. So examples from the parallelogram is a laptop, computer, and a book are both examples of everyday objects that have this shape. A square or rectangular wall or table is also an example of a parallelogram. In fact, there is more than one type of parallelogram, and in fact, a rectangle, a rhombus, and a square are all types of parallelograms. A rectangle has two short sides and two longer sides, while a square has all four sides that are the same length. So while the quadrilateral is a two-dimensional geometric structures. So that a quadrilateral is also frequently called a polygon that has four sides. The part of the term quad means four. So there are many different types of quadrilateral that can be found. Each of these quadrilaterals has their own specific set of properties that further characterize and define the shape. The sum of all the angles that are found inside or the interior of simple quadrilateral all adds up to 360 degrees. So there are types of quadrilateral. In fact, all parallelograms are also classified as being quadrilaterals, as they have four sides. This means that a rhombus, square, and rectangle are quadrilaterals. Even a trapezoid and a kite are also types of quadrilateral. So, for example, a square table or a rectangular wall of a house are shapes that are quadrilateral. A kite that somebody flies is also quadrilateral, and there are many more examples of quadrilateral that you can be found in our surroundings. So we have here trapezoid, versus triangle. Now, let's look at triangles. You probably heard of a triangle. A triangle is a two-dimensional shape with three sides and three angles. So, to find the area of a triangle, we take 1/2 of its base multiplied by its height. So, area of a triangle is equals to 1/2 base times height. And while the trapezoid is a four-sided two-dimensional shape with two parallel sides. So, ano siya ang guys? Ang triangle, mani siya. Kana. Sorry for that. So, trapezoid is ana siya. Ana siya, guys. It's a two shape with two parallel sides. Trapezoids have two bases. Kani siya guys, kani o kani. Those are the sides that are parallel. To find the area of a trapezoid, we multiply 1/2 times the sum of the base times the height. So area of a trapezoid, 1/2 times base 1 plus base 2 times height. So that would be all guys. Thank you for listening.